Hello, and welcome to my yet-to-be-titled game and the dev blog that's going along with it. So today I'd like to show off a little bit of the progress that I've been working on. I've only been working on this particular demo a couple days. It's not much of a game yet, but it does certainly use some interesting technology. So first of all, I'd like to show off this wonderful terrain that I've made with World Machine, just using some Perlin noise, a little bit of garbage matting, and some erosion and snow. And then inside here, this is the main part of the demo, and the main reason that I wanted to make this demo was I wanted to have support for the Oculus Rift and Google Cardboard and the Leap Motion, just cool technologies like that are just emerging. So here I have the, straight up from the SDK, the Google Cardboard head, and as you can see I've attached a FPS motor to it just so that you can move around a little bit easier. And then over here you can see some lovely Unity Pro water. It's much better than the Unity free, Unity Light water. And I think the most important part of this demo was an effect it took me a couple hours to actually achieve, but I think I got it looking fairly realistic. The Aurora Borealis. This particular scene is supposed to be in the North Pole, as the story or the lore for this particular level is supposed to go. All right, there we go. Takes just a couple seconds to initialize. And as you can see here, it's a very, very realistic looking model of the Aurora Borealis. I'm not going to say it's totally efficient yet. I do use quite a lot of vertices in the billboarding, but it is very, very realistic to real life. I used numerous photo references for this, and ooh, I have some render queue errors there. But, okay, so as you can see, the main effect, if you start to deconstruct this, you can see slowly texture moving along back there. If you look in very closely at some of the, oh, I forget what it's called, but you can slowly see that texture moving back there. And what I have that moving, that's just a basic particle system texture that I have changing opacity and color over time. And then over here, I'm using the velocity over lifetime, the random between two curves, to give that a little bit of width. And this is basically the backing for the effect. This is what ties it all kind of together. And then inside this particle system, I have a sub-emitter that it's basically the same texture, just squished up a little bit lighter. And I have it a little bit brighter and a little bit more green. And the way this works is instead of moving along with the effect, it kind of stays still and fades in and out very quickly. And I found that's the most realistic to most real-life references. So yeah, that's kind of how I achieved this effect, and it turns out really nice. Like, as you can see, it's very realistic. So yeah, and the best part about it is, if you can see this curve here, this is basically a top-down view of where the actual Aurora Borealis happens. So it's very customizable too. You can make it take any path you want it to take. So yeah, this has been DevBlog 1. Ooh, actually, before I end the video, it would be foolish of me not to show what it looks like actually playing with the Skybox. So there we go. It's high resolution enough. I mean, I am recording, so it's going to be lower, of course. And this is going to be running on commodity hardware, like a handset, inside Google Cardboard. So, whoops, don't try to move the camera at the same time. There you go. So as you can see, it's very light, but it is actually reflected properly inside the water. That was something I was a little bit worried about. And it interacts very well with the Skybox. I find the Starry Night default Skybox, ooh, and you can even see the sliding texture there a little bit more. But it works very well with the sliding Skybox, I find. So yeah, this has been DevBlog 1 on the yet-to-be-titled game. I hope you follow along to the next one, and I'll see you next time. Goodbye.